Hey guys, how you doing? Ron Zanut here. Right now I've got a Koolance TMS-205. It's the thermal software interface controller. Actually, it's a hardware circuit card assembly, but it has a software interface that you can use to control your water cooling or your cooling in your system here. What we got inside this guy here is basically an installation guide from the manual. And it identifies the different connections. You'll have power connection and some flow meter connections, so you can check the flow of your loop. Also has a power connection to control the PMP 400 or PMP 450 pumps, and I guess you can also control an MCP 655 with it as well. Basically the same thing, although the 450 and the 400 come with a TAC lead on it. And then it also has ports for temperature sensors as well, so you can run some temp sensors, and then it connects through a USB connection to control the board with the software. There's also a TMS-200, which is an expansion card that gives you another set of temperature sensors and fan power connections, and also a pump and another flow meter. So you can basically control 2 pumps and 2 sets of fans and 2 flow meters. So it gives you some expansion capability, and I've got that here as well. So I'm going to be installing that on the onto the 205 as well. So and actually the model number for this is a TMS-205 extension board, and this actually they moved this as a TMS-205. It used to be a 200. Looks like they updated some things on the on these guys here. So we've got instructions inside the TMS-205. We've got one long fan power lead. We have 3 shorter versions, 3 fan power leads that extend fan cables. We've got an adapter for Molex power adapter. We've got an internal USB header. So remember, this has got an interface with USB. So there's a connector on the motherboard that connects to this, and then this goes right into an onboard USB connection. Here's the external one, so if you don't have an available internal one, you can just connect it. There's a port on the board that takes a regular USB, and you run that to a USB port on the outside of your case. It's got 5 thermal probes, so like the ones you get with your motherboards, some of your high-end motherboards, you've got thermal probes that you can connect up to this controller to check temps. And let's see, we also have a power switch adapter. Okay, this is a power switch adapter that you can interface with your board and set it so if the controls in the software or the pump or the temperature gets too high, it can shut down your system. This will connect between your power switch on your case and this board, so the board will tell the system to shut down. So that's what this is. And then we have the board itself. Alright, so on the board here, I can get you maybe a good close-up so you can see the card. We have going from left to the right, looks like there's a sync switch for one of the flow meters. This is where the flow meter that I have that's going to plug into it. I have the INS FM18, I think it is. And there's another probe here. This is where your pump connects. So your pump will connect to this, and then the power coming through here, and this regulation circuitry here will control your pump. I'm not sure what the ATX is. Oh, that's your ATX power switch. That's where that power connection comes in, so that your system, if it runs into thermal problem that you or level that you set, it'll shut it down. And we have 1, 2, 3, 4, 5 thermal probe connections, and then 3 fan connections, and then here's the internal USB connection, and then over here you have the USB header for the regular USB port. And then I believe this connector is to mount where the extension board goes. Okay, we get the board out. We have some hardware, some screws, and we have the board itself. This is a TMS-205 main board by Koolance. And let's see, we'll start, let's see if we can get a good look at the card. And then we'll go around here. This is the the main power input to the board, the Molex connection. And you have here a sync for one of the flow meters. There's a sync switch for that. I think that's, well, I'm not sure. This one here is for the flow meter that I have. It's the INS FM18. There is another type of flow meter that you can connect here. And then here is a connection for your pump. So your pump will be plugged into an adapter that goes to this point here. So it's a 3-pin header, but power comes through here, regulated, and then controls your pump. This is the ATX switch connection, where this cable will interface with your main ATX power switch from your case to here, and the software and the system tells it it's dangerous, and whatever setting you have, thermal, temperature, whatever, it'll shut it down, or if a pump fails it can shut down your system. Then we've got thermal connections here for 1, 2, 3, 4, 5 of them. Then 3 fan controller ports, 3 fan ports right here. And then this is the internal USB port, so if you have a USB header on here, you can use in your system, you can connect to that and run it, or if you don't, you have to run it outside your case. You've got this USB connection here. And then I believe this is for mounting the expansion board, the TMS EB205 would be mounted on here, which I'm going to assemble. So that's the circuit card. I'll put him over here. Then included with it is a bracket, so you can mount this so it is in one of your PCI slots. So this allows you to mount the board to that. Or, which I'm going to do, there's a tray. So this tray allows you to mount the card on it. It's got some mylar on here, so circuit card doesn't short to the aluminum. But I believe that's the plan. I'm going to have that mounted on here, and then inside one of the bays there's some space in the case. Alright, so that's the TMS 205, and now let's take a look at the expansion board. The expansion board, of course, comes with an instruction. Looks like the exact same instructions you get within the expansion board. We get another long fan controller extension for your fan. Since it also has 5 thermal ports on there, there's 5 more thermal probes. It also has 3 more fan controller points on this card, so there's 3 adapters. And we have looks like a standoff and a screw to mount it onto the main board. And then we have the card itself. And it looks like it's just a mini version. It is the TMS EB205 Rev 1. Hopefully. Alright, and then over here we have that same sync and a flow meter. 2 different flow meter points here, 2 different flow meter types. And then we have the pump power right here. So we'll have a second pump here. Then you have again 5 thermal points, thermal probes that you can put on here, and then 3 fans that you can control. Alright, so I'm going to, and then here's some of the header pins to connect onto the TMS-205 main board. So I'm going to go ahead and install this now onto the main board. Alright, the expansion board has a couple of holes here where it will rest on the board, and so right here at the bottom of this card is a point to mount a standoff to, and then this pin set will go on this, and it's supported by that header, and then this other one is supported by this header, but over here there's nothing, so I'll be mounting it to that using this standoff and one screw in the bottom and another one on top to secure it. So, alright, I have the standoff installed here, and a screw in the bottom and a screw in the top, and aligned the pins with the headers on the board, and one on this side as well. So we have the thing assembly done, and it says many times in the instructions to make sure that when you're done that the headers for your thermal and the fans are all oriented the same way. So you can install this card backwards. If you do, when you turn it on, you're going to fry the whole thing. So it should look like that when you assemble it. Next, since I plan on mounting this in a bay or in the case and not in the PCI slot, I'm going to mount it on this. So I've got to orient this a certain way and install the screws. So I'll do that next. Alright, I have it installed on the tray, but one thing to note is the screws that they give you to mount these on the four corners, they don't, I guess they either bottom out or they don't go down all the way. I wasn't going to force it. I tightened up with the screwdriver as best I could, but it floats. It floats on that on there. So I think I'm going to find some washers or something that I can get a more secure fit. Even though it just be sitting flat in my case, I might secure it down. I mean, you can mount it in a bay, and they have the screws that allow you to mount those to them. But I don't particularly like that. So I'm gonna see if I got some washers or nylon washers that I can use to secure this down. Well, I did find some washers and some grommets that I've used with, I guess, for mounting hard drives and some fans. So I'm gonna see if any of these will work and do the job. Alright, I had actually 8 of those thin nylon or black rubber washers, so they're good insulators, and I put one on the bottom under the board and one above it, and now everything's nice and snug and insulated, and it raises it off the off this tray some, even though there's that mylar plastic underneath there, so the board doesn't short out. That brought it up just a hair anyway. So that's the assembly. I'm going to find a place in the case to put it in, and then once I have it all cabled up, I'll tell you what I'm controlling. I mean, I definitely have some flow meters. I have a flow meter, so I have one flow meter in the case. I only have one loop, so that'll be connected up to, I think it's an INS FM18, that'll be connected here. I have 2 pumps, so I'll have one pump connected to this one here and one to the expansion. I have thermal probes. I have 3 thermal water that are in the loop. They're the Aquatung. There's one coming out of the first rad. There's another sensor coming out of the second rad, and then the third one is coming out after it gets heated up by the CPU and the RAM blocks don't heat it up, but after the loop before it goes back into the reservoir. So I've got 3 different thermal sensors, so I'll have 3 of those recorded here, and then I am going to take some of these probes and put them in certain places in the case. So I'll probably be putting one, since I currently don't have a water-cooled graphics solution yet, I will be putting one by the graphics card, and I'll probably be putting one in somewhere lower in the case and one higher in the case. Maybe even on the X79 chipset, the motherboard chipset. So I'll be using 5 to maybe 6 thermal sensors. Fans, I'm not sure of yet. I have a Kazi Master Pro fan controller, but I think I'm going to try to see how the fan controller works here through the software. The only fans really that I plan to adjust at all are the the intake fans on the front, and then the two in the front, two on the top of the case, and the one in the back of the case. The fans that are on the rads I plan to have on the whole time. So in my PC, that's what, 5 fans, so there's enough for 6 here, so that could do it if I don't do it on the controller, but I haven't decided yet. So that's pretty much it until I install it and test it out. Once I install everything, I'll tell you what I actually connected up and show you some of the output of the software and the interface, and show you some of the readings that I get in my system. Thanks. I have the TMS-205 Koolance thermal management hardware and software installed, and I was just going to take you through it, some of the basic features of it and how I have it connected and configured. This is the user interface. It's called the Koolance thermal management software. This is version 2.1 you get off their website. Basically, you should be able to see here, these are the different sensors that I have, thermal sensors that are on the setup that I have now. With the base board, the main board, the TMS-205, you get these first 5. You get 5 thermal sensors, and by adding the second board, I think it's called the EB205 expansion board, you get 5 more. So you can get a maximum total of 10 thermal sensors. You get connections for a flow meter and a pump, and that's with the base main card too. So, and then the expansion board gives you another pump and flow meter that you can connect. And then for fans, you can also have 3 fans as part of the base for the main board, and then the expansion board gives you 3 more. And then here's a little graph right now that shows the temperature, the communications port. You interface the software talks to the TMS-205 controller boards through a USB interface connection. So there's a connector, and let's see. So there you go. Now, right now, I'll show you and I'll take you through the settings. But right now, I have the 10 thermal sensors. I have 9 of them connected. I have the first one. I have on the the first radiator, the output of the first radiator. So coming out of my reservoir, going into my first radiator, it's a SR1360. I have one thermal probe in line coming out the output, so that's currently showing at 24 degrees C. And then going into the coming out of the second rad, my first radiator, the 360, goes into the second rad. They're in series, so the output of that one is 24 to 24, or about a degree warmer, 24, 25 according to the shown right now. And then I have a temp sense on the input. After everything goes through my loop and going back into the reservoir, I have temp, so I know what my temperatures are coming out of my reservoir, 1 and 2, and then after it completes the loop, going back into my reservoir, so I can see the temperature difference. And as of right now, it's showing about a degree difference. I'm not running anything other than in this program right now, so it's really pretty much sitting at idle. I have a probe in the middle of my case, hanging in the center to get the air temperature in the middle of the case. I have a probe down on the voltage regulator modules, stuck right inside the heat sink there. So that is giving me the temps in there. That's 38 degrees C right now. I have another temp back between the GTX 680s by the SLI connector, back where a lot of the heat from coming out the back of the card, back of the cards is. So that's currently the air in that area is 52 degrees C. Then I also have a temperature probe taped to one of the RAM modules, and so that's the RAM heatsink, and my RAM is being cooled, water cooled. I know it's not a main reason for cooling it. You'll see my RAM, and the bling is the factor for me, not for the cooling, but I do have one tape there, so I know what the temp is on that. Then my LSI controller, the LSI controllers I read can get very hot. They have a large heat sink on the RAID chip, itself, and so I put a probe right on that that heat sink. So that is currently, that's between that and the temperature coming out of the SLI area. Those are the hottest things in my system. So here is a 50 degrees C is what that heat sink is right now. I do have fans, 2 fans, AP 121 Silverstone fans blowing down right in that area. So that helps to keep them cool, and when I turn those fans off, you can actually see the temp go up a few degrees. And I will show you temperature change in some of these guys. I do have one probe that is not connected, so I'm going to figure out a place to put one and put it in the case. So so that one's not connected, and then I have a probe right at the input, the intake of one of my 2 fans in the front that are blowing air into the case, and that is ambient temperature. So the air temperature coming right into the case, unaffected by anything else, is 23 degrees C. So that's your baseline to compare everything to. So the water as it's going through the system right now, 24 degrees C, and then after it's being heated up, again, there's nothing running, so there's nothing heating up the running the processor, other it's sitting at idle, and so it's really just about a degree difference after it's gone through the RAM blocks and the CPU. So just so you can see, I have this is the temps on the cores. This is a 3930K, and you can see here my hottest core is 31 degrees C, and my coolest is 21. And so the average between them is probably, and that really brings it up quite a bit, but 26 degrees C roughly, 25, 26. So, and that, so it's about a degree. My delta between, and this is currently running at stock. I don't have it overclocked yet. So the delta between my water cooling and the processor really on average is about 1 to 2 degrees. So I love the water blocks from EK are awesome, and they're doing a great job, and the system works just fine. Now I'll take you through some of the other features in the system I have here. This shows 2 pumps. So the flow of the pump is 4.6 liters per minute. And that's the flow for between. I have a flow meter in the system, and I'll show you a picture of it. And so I only have 1 flow meter. You can have 2. I do not have a second one. And then the pumps are both running at 3,810 RPM. I do have the MCP 655s, the Koolance versions that have the tachometer to tell you the speed of that pump, and they are connected to the TMS-205 controller board. So and so probably it's a good time. I'll show you. There is a feature that allows you to control pump 1. So you can just pick whatever level, and it shows the voltages there. You should be able to see those. Right now it's set on level 7, and then same thing with pump 2. And then you can, and this is what I use, you can change the pump setting by just selecting all pumps. So right now I have it set on level 7 for both. So you can set them individually or together, and I currently have them running right now at level 7. And I can crank it up to level 8, and then when I do that you should see the liters per minute go up. Actually I'll bring it up to 9. And so here you're already seeing the RPMs go up to 4,380 RPMs. The second one 4410, and then the flow now is 5.2 liters per minute, and that's from the flow meter. Again, I don't have a second flow meter. There's only 1 loop, 1 flow. Alright, now I'm going to bring that back down. I control the pump, so I will have to run it and see what difference in temperatures that might make. So I can set them both to 10 and then watch the temps drop, if any. So right now that's it. Let's see, we'll go into settings. This is base settings for the from the card. You can set the COM port that that USB interface assumes. It's currently set at COM3. You can set it to open up when you start the screen when it opens up. I do. I have it starting with my operating system right away. I don't know if the pumps are automatically default to the setting that I set this to. I'm assuming they do, but I always have it start up anyway, and then I can minimize it. This shows what temperature you want to use, Celsius or Fahrenheit. The flow rate, liters per minute or gallons per minute, and then the graph on the window shows, you know, what is it do you want to see. I have temperatures shown on the graph there. I didn't show you that, but this is a graph showing, and then each one of these is color coded, each of your thermal sensors, and they're represented here in the graph. And you can actually change any one of these temp these names. I called them RAD 1, RAD 2, so all you got to do is click on them. Like most window things, you just click on it and rename it. And then you can, I guess you can change the color coding, whether you want to display it or not. So you would check it, and if you wanted to adjust it, the temperatures in this case, you can set offsets up or down. Then if you wanted to, I don't have any fans connected right now to this. I use my Master Pro to control the 6 fans that I have, or 5 fans that I have running right now off of those. Is not set up right now for me to control the fans on my radiators. I have those on full when I turn my system on. The system is very quiet, so I don't have a problem with that. And here's a flow meter. You can tell it what flow meter you have. And I have the INS FM17. You can also tell it if you have the 16, what size tubing you're using. And then if I had a second flow meter, you can also show them that as well. And I don't know if you can see that on the screen, but it's the very bottom one here. Alright, under the alarm menu, you have each one of those sensors you can set an alarm to. On the TMS-205 controller board, there is an alarm indicator. And one of the things that I found this out the hard way, is I started getting an alarm on my LSI controller. Well, that's because out of the box the system defaults to 55 degrees C for an alarm. The LSI controller runs at about 50, 52, I don't know if you saw it before, I showed 50 some degrees, and when I didn't have my fans blowing down on it, it creeped up to 55, 56, so it was going off. So you can adjust the alarm setting for the alarm, and I'll actually do that now. I will reduce the alarm setting. Let's see, right now the LSI is currently at 49 degrees C. So I'm going to drop this guy from 64 down to 47 and save. So you have it went to red and it automatically started setting the alarm off for you. So I just changed it back up to 67 degrees. So it hovers around 50 degrees, so I gave it a good 10 to 15 degrees as well. And the other thing that you can do is there is a capability on here to connect up a connector between the motherboard, power switch, and this controller card. So if any temp does trigger an alarm, it can shut down your system for you. So if you leave your system on and something dies, as a matter of fact, one of the things that they have in here is you can change it for the RPMs on the pump. You can set it that if the flow, or if the pumps drop below a certain RPM, they default to 2,000. Mine at setting 7 and running around 3,800. you can set it that if they drop between a certain RPM, that it'll also set your system down, or the alarm will go off, certainly. So again, I don't have those set at all. And in the flow rates too, you can set it so that you can get an alarm if anything falls below any of the settings you have here. And then it looks like you can also pick different audio sounds for the particular item. I have not done that. I have the standard beep. I guess your system can do something here. Actually, let's click on it. Don't know. That's a feature I haven't tried. Alright, so and you can set it to silent as well, where if it does go off, it'll just give you an indication in red like you saw before. Alright, shutdown. Here's a shutdown menu I mentioned. So these are your sensors, and here are the current settings that it would attempt to shut your system down. But you have to have the cable installed. It comes with it. I just didn't do it because early on, setting the system up, not knowing what I was doing with it, I didn't want it shutting down prematurely on me. So something that I might put in there. It's a nice safety feature, but I don't leave my system on all day. When I'm using it is when it's on. So I'm not too concerned right now about that. But then also it shows you right here that you have capability to just to power off the hardware or use the operating system to shut it down. So that is what it's default for, and then it gives you a 60-second delay once the temperature is reached that triggers the shutdown. All right, so that is there. Fans, as I said, you can adjust each fan just like the pumps that I showed you before. So you can adjust the speed, the percentage of the voltage going to those fans, and or you can set them all in one foul swoop. So I don't have the fans connected up right now, so I'm not using that feature of it. Here's the pumps that I showed you, and then there's a log, which I've used already. You can set a log for recording temperatures, fan speeds, pump, flow meter, whatever you wanted on that chart. You can select them, and then you can set it to record. So it actually starts right from here. You can tell where you want the file created, and it will do a continuous recording if you want, or record for a certain time frame. And that's basically recording everything you're seeing right here. And then this is the viewer that allows you to go and open a file, and let's see if you can see it. I do have one. Here's a bunch that I did. Here was one when I was running Intel burn-in. So let's see if you can see it. Here is for whatever period of time that was. It looks like I had it running for about 7 minutes. There's a timeline down here, right down in the bottom. I don't know if you can see that, but I guess you can't. But here it is. Here it shows each of them, and then it also is showing the items that I had that I was recording. It shows their color and their names, and it also shows the minimum, the max temperature and the min temperature that was recorded, and then this was the its temperature, the last the last temperature recorded before I stopped capturing. So I think it gives you plenty of tools to be able to analyze the cooling capabilities of your system, and I particularly like being able to see all of the temperatures for all the probes that I have set in one nice little screen. You're able to label them something meaningful for you, and then obviously a key to measure anything against in this system is either you got to know what its baseline temp is, and which I've established by using the system now. Nothing has failed, but the key is, especially has your cooling for your water cooling components work with regards to ambient. So at least for me now, against a non-overclocked system running at 24 degrees C at idle with an ambient of 23, that's 1 degree. That's pretty damn good. But that is just the air and the water temps, and then again, if you were to average out my CPU cooling Again, you're looking at pretty good. It's only a couple of degrees on average above what the water temperature is. So, all right. So now I'm gonna give you some shots into the system, so you can see where all of my probes are, and the Big Bang Kick-Ass XPower 2 Kick-Ass build. So I'll take you through and show you where each of the probes are positioned, and also give you a description of up near the top there where that thermal controller is installed, and I'll show you where all the connection points are. So I will do that now. Well, here's TMS-205 installed, and I have both the expansion card mounted on top of the main controller card. That's the expansion board 205. And so I'll take you through the connections that I have on the board. Hopefully you can see some of them. First one is a sync switch, and that is just set to on. The next one is for flow meter number 2, which I don't have the particular one that goes in there. I have a different flow meter, and that's in FM1, if you can see right next to it. And that is this flow meter right there. That flow meter cable connects to the flow meter 1 port. Then next to that I have let's see, here it is, pump. Okay, so where you see pump 1, I have that running to one of the PMP 450. It's got the variable control. You can either adjust it on the side of the pump right there, or by using this card you can actually control it software wise. So you can set the pump voltage so it reduces the speed and the flow rate and everything. So that's for pump number 1. Going across the bottom of the card, thermal probes that I have installed in there. I have thermal probes 1 through, there's 10 of them on here. There's 5 on the base card. 1, 2, 3, 4, 5. You can see those. And then on the expansion card there's another 5. But there's also 3 fan controllers, control points that you can adjust again through the software. Those I'm currently not using. So fan 1, 2, 3, and then up on the expansion boards, fans 4, 5, and 6. I currently am not using those. I have a fan controller, the Master Pro Scythe, in the front of the unit, and that's what I'm using there to control my fans. My other fans that are connected to the radiator are just on. When the system powers up, they're connected to a BITS Power X station, and they're powered on the whole time. That is a USB, an internal USB. There's an external USB header on the front of that card right there you can use, but I'm using that, and I'm running it right to a port on the motherboard, so that that guy runs through the system into a port on the motherboard. So I have the USB connection for controlling with the software. Then on the top controller you'll see there is a connection right there for pump 2, and so I have pump 2 right there connected to the second pump, which is on the other side of the RP 452. He's on the other side of that that reservoir pump setup. And then as we go down further, I have 5 more thermal probes, actually 4 of them. Number 9 is empty. I need to, I'm going to populate that with one here. I'm not sure where I'm going to put it yet. And then the 3 other fans. The other feature that this controller has is a power connection. I don't know if you can see that, but there's one called ATX right there. And that is right next to the pump, that ATX controller allows you to install a cable between here and your motherboard power on switch, so if the thermal temperature of one of your settings gets above the max, it'll shut down your system for you. Now, I currently am not using that right now. I wanted full control over my system. Not fully sure how to set up. Well, I've been using it now, but I wasn't sure how to set it up, so I didn't want the system being turned off prematurely for a low temperature setting that I didn't know how to fix. So I may use that at a later point. So right now I've used all the features of the card except for the system automatic turn off and the 6 fans. Everything else on this card is used. I will be adding the final temperature probe to a point in the case. So now what I'll do is show you each of the probes and their positions where they're connected. Okay, see that little lead right there? I got blue tab with the metal fin hanging down. That's a temperature probe. That's where I measure my ambient. So that's the air, measuring the air coming into the case from the front. So here's the front of the case, the lowest fan. That's bringing the air in, and that is where I'm taking my ambient temperature measurement coming into the case. So that is actually the coolest, not bringing the air right into the case here. So that is one of my temperature probes. A second one is coming out of, there you go, you can see that black collar around the output of that reservoir. That's the output of rad 2, so that's the SR1 480, and so that gives me the temperature of the coolant flowing out of that rad before it goes into the first RAM block. There's another one, and you should be able to see it possibly right there. There's another one on the rad right there, another collar, and that is another inline flow meter from Aquatong, and that measures the coolant temp coming out of the first rad, and that's an SR1 360. Alright, the next one, I have a probe hanging right there, and I call that one in the center of the case. So that's just the temp from the center of the case right there. And then the next probe I have is back here, right between the underneath the SLI bridge between the GeoForce cards. So it's measuring the temperature of the air coming out around those cards back there, and that does get pretty hot, especially with those two cards being so close together. This first card is, I mean, I've measured it almost 20 degrees more than that second card during certain applications. I do have triple screens running and everything, but that's significant. So I'm curious to see how the temperature changes between that and the and running it with water cooled. So I have to remember to do some screenshots of the temp as it is now, so you can see the difference between that and water cooled. Alright, so the next temp probe is, I don't know if you can see, running right into the voltage regulator module. Right in that black eye there is a probe that goes, let's see if you can see it, there we go, that little cable right there, the little black single one, that probe goes right inside there where that's the heatsink for the voltage regulator module. So that temp is on there. Then there's also another temp on the RAM. You see it hidden away, taped down with a piece of that copper tape right onto the RAM heatsink. So I've got the temperature of the RAM as best that I can get it. And let's see, what am I missing? Oh, there's also another one of those collars, the Aquatong on the inlet. So coming into the reservoir, I have the temp after it's been of the coolant after it's been run through the whole loop. Alright, so that is, so we have ambient, rad 1, rad 2, reservoir 3, center of the case, SLI, RAM, and the VRM. So I believe that's it. That's all of the probes that I have in this case. And I will add one more, but I'm not sure where that's going to be. So I'll let you know when I figure that one out.